Okay, I'll share my screen now. Sorry for this. Yeah, can you see it now? Is my screen visible now? Can somebody confirm?
Yes, sir.
Okay, good. Maybe I'll start from the beginning. Let me start from the beginning. So what I was saying is we'll cover linear algebra from this session onwards, and I was asking you to note down one important website that will help you a lot in GATE CSA preparation. That is called GATE Overflow. If you go to the website, you can search for 3 volumes of books that this website has released, and that book contains solution to previous year GATE questions. And the best part is the questions are organized into chapters, into subjects, into chapters, and topics within chapter. Right. So the questions are well organized, and the solution is also kind of elaborative, which means you'll be. It should be easy for you to follow. So I highly recommend that you download this textbook. Sorry, not textbook. Download this material and follow it and use it for your preparation. Right. So and then I was flashing the mark distribution from linear algebra over the past 5 years in GATE CSC. So what we see here is on average you can expect around 2.6 marks from this topic, and the syllabus of this topic is also not very vast. All you need to understand is some properties of matrices, properties of determinants, and you should understand how to solve system of linear equations, right? Then you have eigenvalues, eigenvectors. So here more than the concepts, the properties of eigenvalues and eigenvectors are very important, right? It may be unreasonable for us to ask a question like get the eigenvectors of a 4 cross 4 matrix. That is very computationally intensive, and that is not expected, right? So instead, the questions will be tricky questions in the sense you can find out the eigenvectors using some properties. So you need to understand the properties, and you need to know when, where, and how to apply these properties, right? And finally, we have LU decomposition. LU decomposition is just one technique, perhaps that we will cover in the future, right? So what I'm saying is, if you prepare from these 5 topics, you will easily get a 2.6. You can expect to get 2.6 marks in GATE. That is why I'm saying this subject is very important, not just for GATE, for any field of mathematics. If you ask me the like what is one subject that applies across fields of engineering, I would say it is linear algebra, right? And maybe a precursor, like because we are CS guys, I think you must have heard the jargon machine learning, AI, etc., etc. So machine learning, AI, LA is like in the heart of these subjects, right? So LA is used extensively in data science everywhere. Yeah. So we'll start the session with system of linear equations, and in general we'll see how to solve system of linear equations. Now the first question I asked you was, what do you mean by solving equations? Right? So let us see what a equation is. How does it look like? So for example, x1 plus x2 equals 2 is a equation. Right? Now what are unknowns in this equation? Unknowns are variables, or these symbols that are present in the equation. These are called unknowns. Now what do we know about these unknowns? We know that if you add them together, the sum should be equal to 2, right? Now what is the solution to this equation? Solution to the equation is any value that when substituted to this unknown, this equality holds, right? So for example, I can substitute x1 equal to 1, x2 equal to 1. This is a valid solution to the equation. Why? Because if I replace these unknowns with 1 comma 1, I get a 2, and which is equal to RHS. Right? Now this equation admits many solutions. What do you mean by that? I can substitute x1 equal to 2 and x1 equal to minus 1, right? And still you see that 2 minus 1 equals, sorry, I should substitute x1 equal to 2 and x2 equals 0, right? This also is a valid solution to the equation, right? So now we understand, what is an equation, what is solution to an equation. Now let us see what do I mean by system of equations, right? When I say system of equations, I think you would have already guessed that we have not one but many equations. Now what do I mean by many equations? For example, I can have x1 plus x2 equals 2 and x1 plus 2 times x2 equals 3, right? When I say system of equations, I have one or many equations in general, right? Now what do I mean by system solution to system of equations, right? Always you remember, a solution means an assignment to unknowns in the equation. Now even though I have two equations here, the unknowns are nothing but x1 and x2, right? Now earlier we saw what is a solution when I have one equation. Now when I have system of equations, you will give me an assignment. For example, let's say you give me 2 comma 0, right? Now when I substitute, so you will call this candidate a solution only when this when supplied to unknowns in the equation, all the equations in the system should be consistent. Now for example, when you substitute 2 comma 0, you see that 2 plus 0 equals 2, which means first equation is satisfied. Whereas if you substitute to the second equation, you get 2 plus 0 equals 2, which is not equal to RHS, right? Because this so-called solution violates one equation in the system, we cannot call this as a solution, right? The values that you substitute to this equation are called solution when the values satisfy all the equations in the system. Now for example, if I substitute x1 equals 1 and x2 equals 1, you see that this is a valid solution. Sorry, 1 comma 1, right? Why is this a valid solution? When you substitute to first equation, you get 1 plus 1 equals 2, and when you substitute to second equation, you get 1 plus 2 equals 3. Now I hope solution to system of equations is clear. Now we need to understand one more qualifier, linear. What is linear, right? We call something as linear, I mean an equation as linear when the unknowns are raised to the power 1 and the unknowns do not mix up, right? So I have given you two terms here. So there is a mathematical definition of linear. Perhaps I will not go into it. Let's keep this talk very at an intuition level, right? So what I'm claiming is an equation is linear when all variables in the equation are raised to the power 0 or 1, right? And and the variables should not mix up. Now I think the first condition must be clear to all of you. What I'm saying is, if you have an unknown x1, its power should be either 1 or 0, right? Now I think power 1 must be clear. Now let's see what will happen when, what do you mean by power equals 0, right? For example, this is also an equation, x1 plus x2 minus 2 equal to 0. Basically this equation and that equation is same. I can sort of write at minus 2, this part as minus 2 times x1 times 0, right? Yeah. So this is x1 raised to the power, like 1 or 0. Then second condition I'm saying is the equation should not mix up. What do I mean by mix up? So for example, this is not a linear equation. X1 plus x2 plus, let's say, 2 times x1 x2 equals 0. This is not a linear equation because you have a term where x1 and x2 appear together, right? This is not a linear equation. All right. Is there any doubt so far?
No,
Okay.
sir.
Yeah. So maybe I'll ask some quick questions. Can you tell me if this is a linear equation? X1 square plus x2 equals 3. Is this a linear equation?
No, sir.
Yeah. Is this a linear equation? X1 x2 plus x3 equals 0.
No, sir.
Yeah. Why? Because there is mixing up happening here. Right. Now, why are we bothered about systems of linear equations? Right. Now, in engineering, in many branches of engineering, um, like many nice solutions depend on system of linear equations, right? And it turns out that if the system is linear, if the system of equations is linear, we can solve them very, very efficiently using properties of matrices, right? So in this class, we are going to see how to exploit matrices in obtaining solution to a given system of linear equations. All right. Now, the first thing to do is, for example, here I have a system of linear equations. First thing we have to see is how do I represent these equations in a matrix format, right? So let me give the matrix format, and perhaps I will give you 2 minutes to see if what I have written is appealing to you. Okay, so or maybe let me go to systematic way. Let's call this equation one, and let's call this equation two, right? Now, to represent the matrix in a linear format, you need to separate the constants in the equation, right? So, constant is something that does not have a variable attached to it, or as we saw in the last slide, these are variables that are raised to power 0. You can treat it any which way you want, right? Now, the first step is to separate the constants and bring them to right hand side. Now, what do I mean by that? In the question, they might have given you 2x plus 7y minus 34 equal to 0, right? The first step what you should do is you should bring the constant to the RHS, right? Then let us fill the matrix later maybe, right? So this matrix let us call as A, and the unknowns let's call it as X, right? Now second step is you need to identify what are the unknown variables in the equation, right? Now across the system we see in the for example in the first equation I have unknowns x comma y, and in the second equation I have unknown again x comma y only. So to this system you need to substitute values to x comma y, right? So this x you can fill immediately. X you will fill in the unknowns in a column vector format. X comma y equals, and the right hand side I will call it as p. Right hand side is very simple. So whatever constants you have, you are going to simply supply it. 34 comma minus 1. Now we will see how to fill in values of a, right? Now um, if you have two unknowns in the equation, basically a will have two columns. So the row why is my pen not writing? Oh no. Yeah. So the rows of the matrix A. Oh, sorry. I think there's something happening with my system. My pen is not cooperating. Let me fix that. Oh, what happened? Yeah, sorry guys. Give me just 1 minute. I'll try to fix this. Okay. So, hello. Are people still able to hear me? I think my laptop just got hung. Are you able to hear me? Are you still there? Ah, okay.
Yes.
Yes.
Yeah, maybe I should change this to PDF. Maybe. What is happening? Okay. Maybe I'll open a PDF reader. Sorry about this. Yeah, my system is not responding. Okay. So let me open. Let me open draw board. Yeah, sorry for the inconvenience. Um, Let me create a fresh page. Okay, so I'll copy the matrix here. 2x plus 7y equals 34, 5x minus 4y equals minus 1. Okay, let me increase the size. So is this thickness fine? Okay, I think it is fine. So the equations that we had was okay, 2x plus 7y equals 34, and 5x minus 4y equals minus 1. 5x minus 4y equals minus 1. So when I said system of linear equations, we need to construct a matrix format, something like this. This matrix we call it as A, and I told you the next vector is going to be the unknowns in the equation, and we found that the unknowns in the system of equations is x and y, right? And you will write, let's call this vector as x, and in the right hand side, you will simply put the constants. And the one thing you need to remember is this constant should be in the right hand side of all the equations, right? Had this equation been 2x plus 7y minus 34 equal to 0, you will rewrite the equation by bringing all the constants in the equation to the right hand side. Once you bring it to the right hand side, you will simply fill in the column vector here, 34 and minus 1. Yeah. Okay. So now we are going to see how to fill in the entries of matrix A. Now the rows of the matrix are going to span equations, right? And the columns of the matrix are going to span unknowns. One important thing is these columns will span unknown in the same order of x. What do I mean by this? Now let's say somebody has given you the equation 7x plus 2y, sorry, 7y plus 2x equals 34. Now again you will read this kind of equation so that the terms, the order of terms is in consistence with whatever x vector you have here, right? So in that sense, what you will do is to rearrange this equation and write as 2x plus 7y equals 34. Right? Now once you rearrange the terms in the equation in this manner, then what you will fill in a is the coefficients of equations, right? So here the first row you will fill coefficients of the first equation in the order x comma y. So the first entry will be 2, second entry will be 7. Similarly, in second row you will fill coefficients of the second equation, that is 5 and minus 4. Right? Now I'll give you a simple exercise. I want you to do it. I want you to construct the matrix format now. So let's say the system of equations is 2x plus 3z minus 4y plus 5 equals 0, 2z plus 6 equals 3. Can you write the system, can you represent this equation in ax equal to b format? So can somebody tell me what you will put in the in this vector here?
0 and 3.
0 and 3 will go into b, right?
Yeah.
Yeah. What will come into x, vector corresponding to x? This capital X.
X, Y, Z.
Correct. X, y, and z. Now what will come in matrix A?
That the first row will be 2, 3.
I think you made a mistake in 0 and 3 here, right? So you already made a mistake. Can somebody correct B here?
Sir, it will be -5 and -3.
Correct, correct. So you cannot simply put the RHS of the given equations. First step is to bring the constants to the RHS, right? When you bring the constants, it will be -5 here, and here's the second entry will be 3 minus 6, right? So this is x, this is the B, and x you have filled in the unknowns in the order x, y, z. Now you have to fill in the matrix A.
So the first row should be 2, 3, minus 4.
Is it 3? So remember, like if you make x this vector x in the order x, y, z, you should fill the entries in the order x, y, z only, right? So it is not 2, 3 minus 4. It should be 2
Yeah.
minus 4 and 3.
Yeah.
And what will be in the second row?
0, 0, and 2.
Correct.
0,
0,
and
0, 2. Right? Now you can confirm that, like if you multiply this matrix and the vector ax, you will get exactly these terms here. Okay. Now we'll see what do we mean by solving system of equations. Uh, yeah. Yeah. So now from now on, I'll take only the matrix format of the previous system. So basically, you have a matrix equation here, right? That is 2, 7, 5 minus 4, 2, 7, 5 minus 4 into x, y equals 34 minus 1, minus 1, right? Now, this we are calling as a into x equals b. Now, can somebody tell me what will x be? So to get x, what I should do? I should take a to the right hand side, right?
So A inverse B.
A inverse b, correct? Now here I will ask one question. This is correct. Now let's say in general I have let's say 3x equal to 6, right? Then what is x? X is 3 inverse into 6, correct? This will give me 1 by 3 into 6 equals 2. Is this correct? So everybody understood, right? How I got x value.
Yeah.
This is not a matrix. This is just a unknown variable, just one unknown variable. When 3x equal to 6, we get x equal to 2, right? Now, can I write this in this format? X equals 6 into 3 inverse, which means it will be 6 into 1 by 3 equals 2. Is this also correct?
Yes, sir.
Yes. Now, can I transform the same logic into this matrix equation and claim x equals b into a inverse? Can I claim that?
No, sir.
No. Why is it a no?
No, sir, it's not commutative.
Exactly. Exactly. So matrix multiplication is not commutative. What do you mean by not commutative? AB, when A and B are matrices, AB in general is not equal to BA, right? So when you multiply matrices, the order in which you multiply is very, very important, right? Now, so here I gave you a matrix equation and I asked you to give me the solution to x, which you told A inverse B, which is correct. But one thing that you should always remember is when it comes to matrices, ax equal to b, right? When it comes to taking this variable to the right hand side, what you should do is you should multiply by a inverse on, you should left multiply. When I, because matrix multiplication is not commutative, when I say multiply, I should specify if it is left multiplication or right multiplication. Now for me to get a solution to x, I should cancel out a, and all of us know the identity that for any matrix, a inverse a equals I. A inverse A equals psi, right? Now what I do, I multiply by A inverse on both LHS and RHS, and I observe that I have A inverse A here. This will give me Ix equal to B, sorry, A inverse B, or, and this equation will give me X equals A inverse B. So the key takeaway from this exercise is you cannot simply write a matrix, invert a matrix and write wherever you want. When you take the matrix to the right hand side, you should be very careful about, are you left multiplying or right multiplying, right? Now, as an exercise, let me give you a short exercise. Let's say the matrix equation is x a equals b. Now, can you tell the solution of x? Yeah, somebody?
I don't know if it is correct or not,
Yeah,
sir.
that's okay.
Is it A inverse B again or?
A inverse b. Okay. So x equals, you are saying a inverse b, right?
Yeah, yes.
Now, did you left multiply or right multiply?
Left multiply.
Yeah. When you left multiply, then you will get a inverse x into a equals a inverse b. Right. Now, is this quantity equal to I? Is there any quantity that multiplies to identity matrix?
A inverse A is I, sir.
Yes,
So,
A inverse A is I, but there is a x in between.
yes,
So you cannot call A inverse, like x A equals x. So we know the identity A inverse A equals I,
yes,
but we don't have an identity that A inverse x A equals I. We don't have an identity.
yes, sir.
So then this step is wrong, right? So then this equation is wrong. X is not equal to A inverse B. Can somebody else try solution to this equation?
X equals B into A inverse.
Exactly. So x equals b into a inverse. Can you tell me how did you find the solution?
I multiplied both side by A inverse,
Yeah,
right side.
right side, exactly. So that right side is very important, right? When you write multiply A inverse, what will happen? A inverse equals B into A inverse, right? And we have an identity that A into A inverse equals I. So from this we get X equals B into A inverse, right? So now whoever that said X equals A inverse B, is this clear?
Yes, sir.
Ah, good. So let me add pages. Yeah. So basically, one. So I think like if the class is about solving system of linear equations, we are mostly done, right? So what happened? You started with a system of equations, and we saw how to represent that in a matrix format. That is Ax equal to B, and we know that given any matrix equation Ax equal to B, X is nothing but A inverse B. And I think all of us know how to invert a matrix, right? So basically, you have Ax equals B, and X is nothing but A inverse B. Now, given a system of equations, you can form the matrix. You can represent the matrix format from which you will get the matrices A and B. Now you invert A and multiply B to it. You get the solution X. Now, are we done?
No, sir.
Why are you not done?
See, we have to find solution for this, right?
Yeah. So maybe let's quickly see solution to this equation. Right? We have a matrix 2, 7, 5, minus 4. So A equals 2, 7, 5, minus 4, and B equals 34 and minus 1. 34 and minus 1. Right? Now, can somebody calculate A inverse and tell me? So, how will you find A inverse? Does somebody know?
Say, for example, if we take 2, um, we can take 1 by 2 into um, 34. That's how we found out.
Ah, no, 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 that is not A inverse. Okay. So, okay, then in the class, maybe we'll see how to compute inverse of a matrix later. So,
Or
for
do we have to find determinant and
exactly. So, A inverse equal to you have this formula, right? 1 by determinant
determinant?
of A into adjoint of A, right? Adjoint of A. So this is how you compute A inverse. But for 2 cross 2 matrices, there's a small trick that will give us inverse directly, right? For this applies only to 2 cross 2 matrices. This doesn't apply to 3 cross 3 or any more matrices, right? So for 2 cross 2 matrix, if you apply this formula, that is 1 by determinant of A into adjoint of A, it turns out that A inverse, what it does is, you take the leading diagonal. What do you mean by leading diagonal? The diagonal that goes from left to right of the matrix, right? Now, the elements in the leading diagonal, you will swap the positions. That is, you will write this as minus 4 and 2. The elements that are not there in the leading diagonal, you will invert the signature. Minus 7, minus 5. Right? Now, you can take this as homework. Like if you do apply this formula 1 by determinant of A into adjoint of A, this is exactly what you will get for A inverse. Right? Now, we formed a matrix representation. We got A inverse. Yeah.
This is applicable to only 2 by 2.
Only 2 cross 2 matrices. You cannot apply this to 3 cross 3. Okay. Now, if you multiply B to it, what is B? What was the B that we had? 34 minus 1, right? If you multiply 34 and minus 1 to this A inverse, what is the thing that we get? Can somebody quickly calculate? So one thing is, like this, these sessions will be useful to you if you when attending, you have a notebook and pen with you and you solve along with me, right? Otherwise, you will definitely forget after the class. So let me solve it. So 34 into minus 4 is how much? Oh, again my pen is not writing.
minus 136.
Yeah, I don't know what's happening. My pen is not cooperating. Yeah, okay. Minus 136, right?
Yes, sir.
136 plus 7, right?
Minus
What is?
129.
Sorry.
Minus 129.
Yes, minus 129. And what is 34 into 5? 170, right? Minus 170 minus 2, which will be minus 172. This is the x that we got, right? Now, can you verify if I think I make some mistake? So we should get 2x plus 2x plus 7y equals 34, and 5x minus 4y equals minus 1. Do we get it? I don't think we'll get that. Maybe I think I told you wrong formula for inverse. Let me just check once. Uh, just give me 1 minute. I'll just check. One. Let's say I substitute 1, 3, 2, and 5. If I calculate the inverse. Okay. Okay. Sorry. I think I told you the wrong thing. So what is happening here is you will swap the off diagonal elements. You will change the signature of leading diagonal elements. Right. So sorry guys. I think I made a mistake in the inverse calculation. So for 2 cross 2 matrices, it is always true that the leading diagonal should swap. That is, this will become 4 and minus 2, and off diagonal elements remain as it is. Is it okay? Or should I repeat this A inverse once again?
Can you repeat?
Yeah. So maybe I'll erase this and I'll repeat it once again. So I forgot the trick. So yeah, let me erase this. Yeah. So how you will compute A inverses given a 2 cross 2 matrices? Given a 2 cross 2 matrix, you will swap the positions of leading diagonal, and also you will flip the signature, right? So this minus 4 will come here as plus 4, and this 2 will come down as minus 2, and the off diagonal elements you will leave it as it is. That is, it will be 7 and this will be 5. Okay. Now A inverse, if you multiply 34 and minus 1, what will you get? 34 into 4 is uh,
34 into 4 is minus 136.
136, right? 136 minus 7, so this will be equal to 129, and 34 into 5 is 170. 170 plus 2, this will be equal to 172.
Yes.
Oh no, there's something wrong again. Sorry, just let me just. So 5 will become minus 1, will become minus 1, 3 and 2.
Hello.
Yeah.
Sir, I think we need to divide the matrix required for determinant matrix one by elimination.
Sorry.
Sir, I think we need to divide the matrix required to determinant of the swapping arrangement.
No, this is A inverse. At last, what they're giving is A inverse. Or maybe let me do one thing. Let me input this matrix right away. 4, 7, 5 minus 2, right? 4, 7, 5, and minus 2. If I compute the inverse, I'm getting 2 by 43. Acha. Okay. But there is a nice way to get the determinant of 2 cross 2 matrix. Okay. Somebody was saying, I think you are right. So we should divide by determinant of A. Yeah, that is something I missed. Okay. Yeah. Let me tell you the formula once again. Um, I'll write the formula once again. Okay. So the step that I told earlier was correct only. So A inverse will be equal to, what you should do is you should flip the elements of the leading diagonal, and while you flip, you will change the signature. You will make this 4 minus 2, and off diagonal elements you will leave it as it is, 7, 5. Now after this, you will divide each element by determinant of A. Right? What is determinant of A? Determinant of A is 40
minus
minus
43.
43. Right? Determinant of A will be equal to minus 43. Now, when you divide by determinant, what will happen? A inverse will be equal to minus 4 by 43, minus 7 by 43, minus 5 by 43, and 2 by 43. Okay. Now, to this A inverse, when you multiply B, that is 34 into 1, you get X. Can somebody quickly do the multiplication? Or, yeah, let me use a calculator maybe.
So 34 minus 1.
34 minus 1 is it? Minus 5. Is this correct? I think it. Okay, so let's check if this is correct. So basically, x we are getting is 34 comma minus 1, and the system of equations that we had was 2x plus 7y equals 34. No, these are not, this is still not matching. 2x will be 68, and 7y will be minus 7. This is not equal to 34. I think the solution is perhaps uh, wrong. So this value should be 34 into minus into 4 by 43 minus 7 by 43. So if I take 43 common, so this should be minus 34 into 4 minus 7 by 43. Okay, nonetheless, I think you get the point. Let's maybe not, we are running out of time. So what I'm saying is, now given a matrix format A, Ax equal to B, you can compute A inverse using this shortcut or any which method. Once you compute A inverse and multiply B to it, you get the solution X. This solution is going to be having two numbers, right? And that if you substitute, let's say here x1 and x2, if you substitute x1, x2 to each equation in your system, equality will be satisfied. Do you get the overall picture? You get the point, right? Is there any doubt so far? Forget about these calculations. If you leave the calculations aside, is there any doubt? Shall I proceed?
No doubt, sir.
Yeah. Okay. Now, for 2 cross 2 matrix, at least we had a like cute trick that gave us inverse easily, right? Now we also saw another system where you had a 3 cross 3 matrix, or rather 2 cross 2 matrix, 2 cross 3 matrix, right? Now for this system of two equations with three unknowns, can you obtain solution to x using A inverse B? Can you obtain solution using A inverse B? Anyone?
couldn't get the question, sir.
Yeah. So here I have, so we saw one approach to obtain solution to linear equations. So first what we did, we represented a system of linear equations in matrix format. By matrix format, I mean Ax equal to B. Now,
Yes,
from this matrix equation, we understood that x equals A inverse B. Now, to obtain the solution, all you need to do is first compute A inverse. Once you did A inverse, you will multiply this multiply B to A inverse, or rather, right multiply B to A inverse. That will give you solution x. Right? This is the algorithm that we
yes,
had.
sir. Yes,
Now,
sir.
I gave you one other system of linear equation where you had two equations, and three unknowns.
Yes, sir.
Right? Now, when you convert the system into matrix format, A is 2 cross 3. A has 2 rows and 3 columns.
Yes, sir.
Now, can you invert a 2 cross 3 matrix? Right? So, to invert, first thing you need to find is determinant. Then you will do 1 by determinant of A into adjoint A. Right? Is determinant defined for non-square matrices? That is the question. Can somebody say me how to find determinant of a 2 cross 3 matrix? Anybody?
No, sir. No idea.
No.
I think there is no possible.
Yeah, exactly. It is not possible because for you to find adjoint, I think the algorithm that you would have learned is first you will take fix a row, you will eliminate that row and column, and you will get a square matrix, and you will find determinant of this thing. Right now, when you eliminate row and column, you have only one row here. For this row, you cannot find adjoint. Right. So basically, the takeaway from here is although you have a nice formula x equal to A inverse B, one thing is it's not always applicable. And when it is not applicable, when A is not equal to a square matrix. Right. Now this is one case when x equal to A inverse B will not work. Let me give you another case where x equal to A inverse B not works. Right. Now let us consider 2 cross 2 matrix A. Let's say it has 2, 3 and 4, 6. Can you find the inverse of this matrix?
Yes, sir.
Yeah. What is that? So let us sorry for the confusion. Let's work out the algorithm that I told you for for finding inverse of a 2 cross 2 matrix. First thing what you will do is you will
Sir,
you will swap
determinant is 0.
determinant is 0. Yes. So in this algorithm, what you will do, you will you will swap the entries and flip the sign. So this will be -6 and -2, and you will leave the ordinary elements as it is. And then you should do 1 by determinant of A. As a friend told, determinant of A is equal to 0. Right? Because determinant of A is 0, this quantity is undefined. 1 by 0 is undefined quantity. Right? So basically, now we have seen two cases where x equal to A inverse B will not work. X equal to A inverse B will not work. Right? One case is when A is not a square matrix, and other case is when determinant of A equals 0. Right? Now there is one other strong reason why we don't use x equal to A inverse B. Now let's say A is a huge square matrix, A equal to n cross n, and let's say n equals some 100. Now take it from me that till date there is no efficient algorithm to find out inverse of a matrix when n is greater than equal to 5. Right? For any square matrix that is n cross n and n is greater than or equal to 5, inverse computation takes n cube time, and this is not uh, appreciable. Right now, we saw two impossibility reasons why you cannot apply x equal to a inverse b, and there is a computational reason also. In let's say a matrix satisfies both these conditions, that is, it is a square matrix and determinant is not equal to 0. Still, you don't want to find a solution to x using a inverse b. Reason is it takes n cube time, and n cube is a huge n cube is very really huge. Okay, now to find the system solution efficiently, we will see one method now, that is uh, system of linear equations by reducing a to row reduced echelon form, right? So perhaps we will take row reduced echelon form to next class, but I'll set up the basis uh, for this RREF form. Right now, let's assume a inverse b is not possible. Let's solve system of linear equations a traditional way. Right? Let's say let me give you some simple system. Let's say x1 plus 2x2 equals 1. X2x1 plus x2 equals 2.5. Right? Can somebody solve solve the system using the traditional way? First thing, what you will do?
Write in AX equal to B.
Yeah, that is matrix format. Now let's forget about matrix format for now. Now, how will you in general solve the system of linear equations? So you are right. You can write it in matrix format and solve it later. But let's see how traditional system will work.
by variable elimination.
Exactly,
By
variable elimination, right? Now to do variable elimination, let's say we eliminate x2 first. Then what will you do?
multiply equation 2 by
Yes.
2.
So equation 2 into 2 will give you 4x1 plus 2 times x2 equals 5. Right?
Yes.
Then we will forget about this equation. Then what you will do? You will do equation 1 minus 2 times equation 2. This is what you will do?
Yes, sir.
Yeah. Then what is equation 1 minus 2 times equation 2? Minus 3 times x1 plus 0 equals minus
4.
4. Right? Now from this what you will get? You will get the value of x1. What is x1?
4 by
4 by 3. Right? Now how will you find out x2?
substituting in the.
Correct. Substituting in any of the equations will work. Right? Now let's
Yes.
say I substitute to first equation. So 4 by 3 plus 2 times x2 equals 1, and 2 times x2 will be equal to minus 1 by 3. X2 will be equal to minus 1 by 6. Right? This is a traditional way of obtaining the solution.
Yes, sir.
Right? Now let us see if this solution is valid. Now for you to see if the solution is valid, you will substitute x1 and x2 in both these equations and check the consistency. Right? Now in this class, without introducing the technicalities, let us mimic the set of steps that you did. Let us mimic the steps that you did in a matrix now. Right? Now I'm going to solving the system using matrix, and we'll in this matrix what we are going to do is just mimic the steps that you did. Okay, so the initial matrix was 1 2 2 1, right? 1 2 2 1 into the variables are x1 x2 equals b is 1 and 2.5. Right?
Yes, sir.
Yeah. So now the first step in solving system of linear equation is to append B to A itself. One, two, two, one, and when you append B to it, what you will get? You will get 1, 2.5. Right?
Yes, sir.
Right? Now, what is the first step that we did? First step one, what did we do? We did equation 2 into 2. Right? Now, in this matrix, R1 is equation 1, R2 is equation 2. So, I can write the first step that you did as
R2 is equal to R2 into
R2 equals 2 times R2. Right? When you do R2 equals 2 times R2, what will be A? 1, 2, 1, 4, 2, 5. Right? Now, are you all convinced that whatever you obtained here, it is being reflected there?
yes, sir.
Yeah. You had 4x1 equal plus 2x2 equal to 5 here, right? When you multiply that.
Yes,
Now second step, what did you do?
subtract R1 and R2.
Yes. R2 equals R2 minus R1. Right? Or maybe you did R2 equals R1 minus R2, right?
Yes,
Yeah. So, but for now, let me always follow the convention that you will only do operations on if you take R2, you will only do operations on R2. Okay. So then I will do R2 minus 2 times R1. Okay. What I'm saying is, at least for the purpose of this session, let us make the equation always of the form R2 equals R2 plus or minus whatever you want. Okay. Now, can you tell me what will happen when you do R2 equals R2 minus R1? 2 times R1. The matrix will reduce to 1, 2, 1. 4 minus 1 will be 3. 2 minus 2 will be 0. 5 minus 1 will be 4.
sir, but we are doing R2 minus 2 R1. Yes, sir.
Yeah, R2 minus, oh, this will be 3, is it?
Mm, no, sir.
Oh, sorry,
We
sir.
are doing
Let's make R2 minus R1 only. Sorry.
yes.
Yeah, R2 minus R1. So 4 minus 1 will be 3. 2 minus 2 will be 0. And 5 minus 1 will be 4.
Yes, sir.
Right? Now, let me separate out the equation again. Can I now this matrix, let me separate again. So what will happen? I'll have 1, 2, 3, 0 into x, y equals 1, 4. Right? Now, if I multiply this column x, y with the matrix A, what you will get? X plus 2y equals 1, 3x equals 4. Correct? Now from
Yes.
here you can see that you can obtain the solution to x from this, because this is one equation with just one unknown. Right? From this equation you can get x equal to 4 by 3. Now once you obtain x equal to 4 by 3, you can back substitute in other equation. Right? Yeah. So now in the matrix format, what it will converge to is, now in Ax equal to b, uh, or rather in this matrix. So this is be a column corresponding to b. Once you find a row that has one non-zero and remaining zeros, you can immediately obtain the solution corresponding to its variable. Right? So for example, this is the A part. Now, after doing these row operations, what you encountered is a row with one non-zero element and remaining all zero elements. Once you encounter such a situation, you can find the value of the variable corresponding to this entry, right? So variable the value corresponding to this entry is x, and we just found out that 3x should be equal to 4, which means x will be equal to 4 by 3. So I will delete this x and I will write 4 by 3 here. Right, now when you substitute, when you multiply this matrix, what will happen? 4 by 3 plus 2y equals 1. 4 by 3 into 3 plus 0 times y equals 4. Do you see what is happening here? So one thing is this 3 and 3 will get cancelled, and this equation is also consistent. And one beautiful thing is you got again now one equation with just one unknown. Right? From this equation you can get y equals 1 minus 4 by 3 by 2. Is it clear to all of you, like the steps that I did so far?
Yes, sir.
Yeah. Is there any doubt so far? This RREF will take in the next class. We are already running over time. But nonetheless, did you understand like how to manipulate the matrix? What is Ax equal to b? How to, given a system of equations, how do you formulate the matrix A and B, and how will you go about solving them in matrix format? We'll see the formal procedure, etc. next class.
Yes.
Otherwise,
What syllabus are you going to cover in the next session?
next session we will see formally how to take a matrix to row reduced echelon form, and from row reduced echelon form how to obtain the solution of X.
Okay, thank you.
Yeah. So this one will cover, and so basically, okay, let me summarize the key takeaways from this class. First thing we started with, we started with understanding what a linear equation is, right? In a linear equation, you have variables that are raised to either power 1 or 0, and you will not have any mix-up, right? That is when you call a equation as linear. When we talk about system of linear equations, we are given one or more set of linear equations, and you need to assign values to the variables such that equality is satisfied in all equations. Right, this is a problem statement. Now we saw that a given system of linear equations can be represented in matrix format, Ax equal to b. Ax equal to b. Right, and from this we saw that we can obtain solution to x by left multiplying a in both LHS and RHS. Right, this left multiplication is very important because matrix multiplication is not commutative. Right, we saw that you can obtain solution to x by A inverse b, but this is not always possible in two cases. One, when A is not a square matrix; other, when determinant of A is equal to 0. So in both these cases you cannot use this solution approach. Now there is one other computational reason why you will not want to use A inverse b to find out solution to x. Why? Because inverse computation is order of n cube time. This one computational reason why you don't want to use A inverse b to find x, even in cases when determinant of A is 0, so not 0, and A is a square matrix. Right? Then we saw how you, if I give you a problem and if you were to use pen and paper, how will you solve system of equations? Right? Then we saw that, like you will multiply some matrix, you will try to eliminate a variable. In this case, we eliminated x2 first. Once you eliminated x2, you will substitute the value of x2 to x1, and you will find the value of x1. Right, now this is how you will solve in a paper. Then we will conclude the class by how to mimic each of these operations that you did. What are the operations you did? You multiplied a scalar to equation, and you subtracted one equation from other. Right, so the set of equations that you do in general can be translated to matrix also, and that is what we did here. When you multiply a scalar, you will multiply that to the matrix. One more thing. So the technical term for this matrix that I have written, for example, you took Ax equal to B, you appended B to A. This is called an augmented matrix. When you refer to textbook, they may call, like augmented matrix. So augmented matrix means A in concatenation with the constant vector B. Okay. Now you will perform the operations on the augmented matrix to the rows of the augmented matrix. So here you did R2 equals 2 times R2, and second I did R2 equals R2 minus R1. Right. Once you do this operation, so what you will do is to, at one point you will hit a row. You hit a row when all but one elements in the row is 0, right? And when that happens, I told you that you can fix the value to the variable corresponding to the non-zero entry. So here we hit a row that is 3 0. Now corresponding to 3 is x here, right? And how will you fix the value? You will make 3x equal to 4, and from that you will get x equal to 4 by 3. Now once you fix value of x, you can substitute, like 4. You can multiply a in this matrix A, or reduce a to the column vector 4 by 3 comma y. Then you will get again one equation with just one unknown. From this you will get the value of other unknown, right? The technical term for this process is called back substitution. So this back substitution will become very clear when we reduce a to row reduced echelon form. All right.
Yes.
Yeah. So next class we'll see how to do it in a more formal manner. Now, if there are students who attended last class, and last class we are doing some pumping lemma proof, right? Do you want me to discuss that proof quickly? I think last class Shashikant was there.
Yeah. I was there.
Yeah. So others, like so this is one question that I was trying to solve last class, but I got stuck. So
Yeah.
this is a follow-up question. So I think linear algebra part of the session is ended. Now I just want to quickly follow up on the last class, so
Yeah.
others can leave, or you're welcome to stay also. So let me go to the solution.
So is it possible that you can change time from 5 to 6 rather than 6 to 7?
5 to 6 will be difficult. This NPTEL, I think, because it's advertised here, right?
Okay.
Yeah, it's difficult to change. Yeah, so I have attached a solution in this Excel sheet. Uh, Sorry, I promised to solve it right after class, but then I did not get time. So I added
Yeah.
this entry only today.
Oh, I understand.
Yeah. Actually, last class I got stuck because the trick in the pumping lemma is to identify the variables u, v, w, x, y.
Yeah.
Once you identify that correctly, pumping lemma simply follows. So last class I think I overcomplicated by assuming 0 par a, 1 par b, 0 par c again.
Yeah.
Right? Now this the proof follows some very intuitive and simple arguments. Right? Now this was a question, right? So you have L equals 0 par m, 1 par m, 0 par m, 1 par m. Correct?
Yeah.
We need to show that this question is not context free. This language is not context free.
Yeah.
Right?
Can you explain
Yeah.
in that?
Yeah. Is it okay now?
Yeah.
Yeah. So this was a language 0 par m, 1 par m, 0 par m, 1 par m. Now to show it using pumping lemma, first you need to assume a pumping constant n. You need to consider
Okay.
just one string, and that string should adhere to the pumping constant. And last class we saw that this n should be general. You cannot assume values to it. You should assume a symbol,
Yeah.
right? So now then you take let's consider the string 0 par n, 1 par n, 0 par n, 1 par n, And now because this is pumping lemma for context free language, you need to split the string into 5 parts: u, v, w, x, y, and the constraint is the v and x part, the parts that you pump, right? So the pumping will happen this way. You will get s prime by u v power I w x power I y, correct?
Okay.
The pumping part, that is v and x, together should not be 0, of length 0. And one other thing is the vwx together should be less than equal to n.
Yeah.
These are the conditions, right?
Yeah.
Now I assumed a pumping constant n, and the string is 0 per n, 1 per n, 0 per n, 1 per n. Right? Now the proof follows from cases. The first claim I make is vwx cannot contain zeros followed by ones followed by zeros, or ones followed by zeros followed by ones. Do you see why?
No, you should explain.
Yeah. So let's assume vwx contains zeros followed by some number of ones, again followed by 0. Now how is that possible? Right? So it should take some zeros from here, from the first part. It should take all of the ones in the second part. Then it should take some zeros from the third part.
Okay.
Right? That is when it will be of the form zeros followed by ones followed by zeros.
Yeah.
Now you have a condition that uwx together should be less than equal to n. But if you do that, the length of the string will be at least n plus 2.
Yeah.
Right? That is why such a case is not possible. If vwx cannot be in the string 0 plus 1 plus 0 plus. That is one or more zeros followed by one or more ones, and then again followed by one or more zeros.
Yeah.
Right? That, so then my first claim is satisfied. You agree?
Yes.
Yes. Now second claim is vwx cannot be equal to just zeros or just ones.
Yeah.
Right? Actually, it can be. For example, the length of vwx should be together less than equal to n. You may say that I will take all ones here. You may say that, right?
Yeah.
But one thing is, if you pump, then what will happen? Only the ones get pumped.
Yeah. Good.
Yeah.
Zero, zero.
Then S prime will contain more ones than zeros.
Yeah.
Right? That is why if you take vwx as all zeros or all ones, that is a violation.
Yeah.
So second claim is valid.
Yeah.
Then the third claim only possibility is the vwx can contain zeros followed by ones or ones followed by zeros.
Yeah.
Right? Now what I'm doing, the string s 0 per n, 1 per n, 0 per n, 1 per n, I'm splitting into boundaries. If it contains zeros followed by ones, let's assume, or ones followed by zeros, it can be only a substring of s1 or s2 or s3.
Okay.
Do you see why? So basically, I'm claiming VWX cannot cross two boundaries. At max, it can cross only one boundary, right? Because
Okay.
if it crosses two boundaries, then basically first claim is invalid. The
Yeah.
number of shifts that can happen is at most one. That is what I mean here, right? It can either flip from 0 to 1 or 1 to 0 or 0 to 1, but it cannot flip 0 to 1 to 0 or 1 to 0 to 1,
Okay.
right? Now Now let's say VWX contains 0 per n 1 per contains a substring of 0 per n 1 per n. Fine.
Okay.
Now you take that. So one thing. So are you okay? This is kind of tricky. Are you convinced that VWX is a substring of S1 or S2 or S3 only? Are you convinced?
Yeah.
You're convinced, right? Now let's take a VWX and pump V and X. So you should pump V and X, right?
Okay.
If you pump V and X, what will happen? Number of zeros and number of ones in the S that you consider will pump will get inflated, but this 0 per n, this 1 per n will not be inflated.
Yeah.
Do you see?
Yeah.
And that is why this claim also will violate pumping lemma.
Yeah.
right? So with this argument, so basically you consider all possibilities of VWX, and in all possibilities when you pump V and X, the S prime that you get after pumping will violate the pumping lemma.
Okay.
Yeah, that is why this is not context language.
Yeah.
Got it?
Yeah.
Yeah.
Thank
Let me know if you have any doubts. Otherwise, we'll end the session.
Excuse me, sir.
Yeah.
Yeah, so I'm new to this class, and
Yes. Yes.
this is my first class
Yeah.
in which I'm joining. So yeah, I'm doing my final year in Ishwar Engineering College, Chennai.
Oh,
So
nice. Okay, I'm also from Chennai.
oh, that's nice. Well, I'm just starting to prepare for GATE, so
Mhm.
I don't know. Like this is my first class, and this is the first time I'm doing something like this. So can you, if it is okay, if it is your free, can you tell me some things for where should I start? I mean,
Yeah. So actually, today I was, like finding books for previous year gate questions. I found this amazing uh, textbook. Not sorry. I'm again saying textbook. It is not textbook. Previous year solved questions, right? So I always say, like from the beginning of the class, that for gate, the mantra is solving previous year questions, right? Uh, so they have released volumes, 3 volumes of previous year questions in this GitHub repository, and they are freely accessible. Right? Let me ping you this link. Okay. So if you go to this link, you will find these three books. Right? Now let's say we studied linear algebra today, right? I
yes,
mean, just a small portion. Now, as soon as you complete this syllabus, what you should do is to solve previous year questions.
okay, sir.
I downloaded the book somewhere. Maybe let me check in the downloads. I'll say, so I was amazed to see like the way they have organized the book. Now let's go to linear algebra. Yes. So this sorry. Yeah. So the linear algebra section starts from here, right? Now if
Yes,
you see here the syllabus, they have organized the questions in terms of syllabus, matrices, determinants, etc., etc.
yes,
Right? Now today we saw like say, we did not solve the system of linear equations yet. Maybe in the next class or in the next two classes we'll complete system of linear equations. Once you do that, you need to solve questions associated with it,
okay,
right? So in this book you will find some questions. uh, Let me see. System of equations, right? So here,
yes, sir.
so now they have a question here. Let Ax equal to be system of linear equations. A is m cross n, B is m cross 1 column vector. X is this thing. Which of the following is false?
Yes,
You
sir.
know? So today we did not get into details. Hopefully, after next 2 or 3 classes, you should be able to solve this question, right? And similarly, for example, yeah, this question perhaps you will be able to solve next after next class. Okay. So what I'm
Can,
saying is,
can you, uh,
sorry.
my net connection was when
Okay, okay. So what I'm saying
there
is,
was a
yeah,
thing.
what I'm saying is, once you start this material, once you learn a material, for example, today system of linear equations, or let's say you're taking architecture and you're learning pipelining or something. As soon as you learn a topic, you need to test your knowledge by solving questions,
Yes,
right? If you're not able to solve some question, which means your preparation is not adequate, right? As many questions as you solve, that gate will be that much easy to crack.
okay, sir.
Yeah, that's the only thing, only preparation strategy I know of.
Okay, so
Yeah,
all the topics that we are discussing, we will be discussing as soon as I
correct. So
after this
this
class.
is linear algebra part of it. You need to start maybe do self preparation for other subjects.
Yes, sir, sure. Will all subjects will be covered in the due course or
No, 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 no,
in the maths?
no. Because for Gate CSE, at least I'm the only allotted person, and we meet only once in a week, right? So perhaps I think I'll be able to complete linear algebra. Uh, yeah. Beyond that, I think it may be difficult.
Okay. Yeah.
Yeah.
So,
But at least I'll try to make sure that all of the relevant syllabus for linear algebra is complete.
yes.
Okay. As I told you that this is a very easy, very easy chapter, I would say. Once
Okay, sir.
you understand whatever I tell in this class, and if you solve the associated questions, so one thing, so just what I teach may not be enough. You need to solve questions, and you need to solve questions and understand the nuances in it. Once this thing is there, then this 2.66 marks is like a cakewalk, right? In expectation, you can expect like 2.5 marks here. Okay, that went off. So, yeah.
So is the differential equation is in the chapter in the course syllabus of GATE?
Oh, that I don't know. Differential equation.
Yeah.
No, I think we have only differential calculus.
Okay.
Differential equations. No, we don't have differential equations. At least in my time, it was not there. Yeah,
Thanks for
yeah, no
So
problem.
in other streams there are multiple sessions are going on for this live mentorship
Yeah,
session.
yeah, yeah, yeah. But for CSE, unfortunately, I'm
I
the
mean,
only person.
obviously it's not possible for you to
Yeah,
take multiple sessions. So do you hope that in coming days like we can have more?
sessions. Yeah, this request should
Mentors?
be routed to NPTEL people if they assign.
Like
Uh,
even when these NPTEL classes which are actually going on right now, they will be free after 1.5 months perhaps,
okay.
because the classes will be over for those NPTEL classes
Mhm.
which is currently going on. So I hope they will be free. So do you expect that they will be assigned to this live mentorship session?
Actually, I'm not sure. I'm not sure.
Okay.
Yeah.
so can you please give us things to NPTEL? Because,
Oh, you want me to mail them?
Yeah,
no,
if you can, say
if
that students or learners want that more sessions should be for computer science session chemistry.
Yeah,
Because
yeah.
if you see that EC and other streams, there are at least 5 to 6 sessions,
Okay, okay, okay.
and for CS there is only one
One
session.
session. Yeah, yeah. Okay, I'll try to find out. Like whom I should send this email.
Okay, thank you.
yes,
Yeah,
thank you.
yeah. Thank you so much. Bye.